This is the Chapter 2 Algebra 1 review. We're going to work the entire study guide 1 through 33. Number 1, the directions say draw and label a Venn diagram that represents the sets of real numbers. This doesn't have to be anything fancy. We went over this problem together in class. You can draw a rectangle. The rectangle tomorrow will be provided for you on the test. The most specific type of number we've talked about is natural numbers. So if we just put an N for natural numbers, around that we're going to put a circle. And then on the outside of the N, we're going to put a W with a circle around it. This tells us that the whole numbers are made up of all of the natural numbers plus 0. Natural numbers are the counting numbers, 1, 2, 3, 4, 5. Outside the W, we'll put a Z. Z stands for integers. And this tells us that the integers include all of the whole numbers and all of the natural numbers and their opposites. So natural numbers are 1, 2, 3, 4, 5. Whole numbers are 0, 1, 2, 3, 4, 5. Integers are 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So Z for integers. On the outside of that, we're going to put Q. Q stands for rational numbers. Rational numbers are made up of integers, whole numbers, natural numbers, and a couple of other types of numbers. We said that any fraction is going to be a rational number. Any decimal that terminates or repeats is going to be a rational number. And then on the outside of that box, if we put R, R stands for real numbers. Real numbers are all of the types of numbers that we've talked about here. There are some other categories of numbers, classifications of numbers, but we haven't talked about those to this point. So these are the 5 types of numbers that we've referred to. All right, on numbers 2 and 3, the directions say identify the sets of numbers to which each number belongs. So the thing to remember with these problems is that there isn't just one correct category to which each of these falls into. There can be 1, or there might be 2, or there might be 5. Okay, so number 2, we said that we're going to categorize them using these: natural, whole, integer, rational, and real. Okay, if we identify the most specific category that this falls into, it will automatically fall into all of the ones that are less specific than that one, with the 5 that we're talking about. So negative 2/3, is it a natural number? No, those are the counting numbers, 1, 2, 3, 4, 5. Is it a whole number? No, those are the natural numbers plus 0. Is it an integer? No, no fractions or decimals are going to be integers. Is it a rational number? Yes, we said a fraction is going to be a rational number. So for number 2, we know that it's going to be rational, so Q, which means that it has to be real. All rational numbers are also real numbers. So for number 2, our answer would be QR. That's rational and real. Number 3. Is number 3 a natural number? No, because it's negative. Is it a whole number? No, because it's negative. Is it an integer? Yes. It's not a fraction. It's not a decimal. We could find that number on a number line. That is an integer. So Z for integer. Next most specific type is a rational number. Again, we said if it's an integer, it has to be a rational number. If it's an integer, it has to be a real number. So for 3, we would have Z, Q, and R. Integers, rational numbers, and real numbers. All right, for numbers 4 through 9, we're evaluating the expression for the given values. A is 10, B is negative 12, C is 1/3, D is 0.5, and F is negative 1/4. On B, it says B minus negative 2. Well, it tells us in the instructions that B is negative 12, so what we end up with is negative 12 minus negative 2. At this point, we probably know how to do that by hand. Hopefully we know how to do it with using the calculator also. We said if we have a subtraction problem, subtraction really just means to add the opposite of a number. So negative 12 plus positive 2. Negative 12 plus 2 gives us negative 10 as our answer on number 4. On number 5, we have C times F plus A. C is 1/3 times F. F is negative 1/4 plus A. A is 10. So once we've substituted those values in, now we need to simplify using the order of operations. We have multiplication, we have addition. So we're going to multiply first. We're going to multiply those two fractions. 1/3 times negative 1/4. When we multiply those two fractions, we end up with negative 1/12 plus 10. Negative 1/12 plus 10. Alright, a lot of us aren't very good with adding and subtracting fractions. So if we wanted to add negative 1/12 plus 10 in the calculator, I'm going to do parentheses. Remember, always put parentheses around our fractions. Negative 1/10. Negative 1/12 plus 10. When I hit enter, I get a decimal. We started the problem with fractions, so I'm going to change my decimal to a fraction. The way we do that is by pushing the math button, the third button down, and then enter. That's going to give us 119 twelfths. For number 5, 119 twelfths. Okay, that would be written as an improper fraction. If you wrote it as a mixed number, then it would appear differently. Number 6. Number 6 says a squared plus b. It tells us in our directions that a is 10, so 10 squared plus b. b is negative 12. Now we have exponents and we have addition, so I'm going to do exponents first. 10 squared is 100. 100 plus negative 12 gives us positive 88. Number 7. Number 7 says 2 times a minus 3 times d. In our instructions it tells us that a is 10, so 2 times a would be 2 times 10. Minus 3 times d. In our directions it tells us that d is 0.5. So looking at this already, we know that if we don't get a whole number as our answer, we're going to write our answer as a decimal because we start our problem with a decimal. Alright, so we have multiplication, subtraction, multiplication. So we have two places where we're going to multiply first. 2 times 10 and 3 times 0.5. 2 times 10 is going to give us 20. 3 times 0.5 is 1.5. 20 minus 1.5, when we subtract those, we end up with 18.5 as our answer for number 7. Number 8, we have 6ab divided by c. So that's 6 times a times b. Remember, an error that a lot of us were making on the first test where we were just literally taking out the a and putting in 10 for a, which would make it 610, and we weren't multiplying those numbers. You were just putting it in exactly in its place, and it didn't really make any sense. So 6 times a times b, that's going to be 6 times 10 times b, it tells us in the directions, is negative 12. And we're going to divide that by c. c, it says, is 1/3. So now we have a complex fraction. We have a fraction as our denominator of our bigger fraction. We said anytime we're going to deal with a large fraction like this, we can think of that fraction bar as grouping symbols that tell us to simplify the top, simplify the bottom before we think of that as division. So on top, what we end up with is 6 times 10 is 60, and 60 times negative 12 is negative 720 on top. Negative 720 divided by 1/3. Well, negative 720 divided by 1/3, to make sure that we don't miss that, I'm going to put it in the calculator. Negative 720 divided by 1/3 gives us negative 2,160. Number 9, a times f divided by d. A is 10, f is negative 1/4, and we're dividing that by d, and d is 0.5. So in this problem, we start after we've substituted our values in, we have a fraction and a decimal. So you could write your answer as a fraction or a decimal. We have multiplication, and then we're going to divide. 10 times negative 1/4 gives us negative 2.5 divided by 0.5. When we divide these two, we end up with -5. So since we ended up with an answer that didn't have a decimal or any kind of remainder, then we do have just our answer of -5. So we don't have to worry about whether we write it as a fraction or a decimal. So number 9 would be -5. Moving on to the next section, it says choose the correct symbol to fill in each blank. Use less than, greater than, or equal to. So on number 10, what we need to do is to change each of these fractions to a decimal, their decimal equivalent, and then we can compare greater than, less than, or equal to. So 3/16, the way I do that is to divide 3 by 16. In the calculator, I would just type in 3 divided by 16 and get 0.1875. 12 divided by 15 gives us 0.8, and then it should be very easy to see that 0.8 is bigger than 0.1, so our sign is going to open up toward the 12/15. So 3/16 is less than 12/15. Number 11, we need to think about along the same lines. -8/11, when we change that to a decimal, is going to be -0.72 repeating. And -5/8, if we change that to a decimal, that's going to give us -0.625. So now we're dealing with two negatives. So really what we want to know is which of those two numbers is less negative. This is negative by 0.72. This is negative by 0.62. Well, the one that's less negative is going to be greater. So our sign is going to open toward the -5/8. -8/11 is less than -5/8. Next section, graph each solution set on a number line. We're given an inequality, y is less than 3. We want to graph all of the numbers on a number line that are less than 3. So I'm going to draw the number line. I'm going to label it with 3. We know that we're going to have some type of sign here, and it depends on what type of symbol we have in our problem. Y is less than 3. Since it's just less than, it doesn't have an equal a line underneath it to say less than or equal to. That tells us we're going to have an open circle. Since it's an open circle, again, because there's not a line underneath, because 3 is not included. And we want to graph all of the numbers that are less than 3, which would be all the numbers to the left of 3 on a number line. So that's what we're going to shade. Doesn't have to be beautiful, just looks something like that. Number 13, we're graphing all of the numbers that are greater than or equal to -2. Again, I'm just going to draw the number line. Tomorrow on the test, you will have the number line drawn for you, but the numbers won't be labeled, so you will need to find the number that's given to you and label that. So we end up with -2. Since this is greater than or equal to in our problem, that tells us that -2 is included in that set of numbers. And then we want to graph all of the numbers that are greater than or equal to -2. So that's going to be everything on this side to the right. And then number 14. Number 14 says x is not equal to 1. So we want to graph all of the numbers that are not 1. So we know that our number that we need to list there is 1. Since 1 is not included in that set of numbers, we're going to have an open circle on 1, and we're going to shade all of the numbers to the left of 1, and we're going to shade all of the numbers to the right of 1. So it needs to look something like this. Just again, be sure that 1 has an open circle on it, and then you shade to the left and to the right. Numbers 15 through 17, we are dealing with absolute value. It tells us in our instructions that we're evaluating each expression for these values. A is -3, K is 7, M is equal to -5. Number 15, we worked in class together today. It says the absolute value of A plus K. So we're going to do the absolute value of -3 plus 7. A mistake that some people made on the last quiz we took is they took the absolute value of -3 and the absolute value of 7 and then added them together. Think of these as grouping symbols, and we're going to simplify anything inside the grouping symbols before we actually take the absolute value. So what we end up with is, when we simplify, -3 plus 7 is 4. So we're taking the absolute value of 4. Absolute value of 4 just means how far is 4 from 0 on the number line. Well, it's 4 places from 4, so it's going to be +4. Don't be tempted to change that to a -4. You're not always going to take the opposite of a number when you're doing absolute value. If it's positive, if you have a positive number you're taking the absolute value of, then you're just going to have a positive number as your answer. On number 16, we have the absolute value of k plus the absolute value of m. K, it tells us in our instructions, is 7, so I have the absolute value of 7 plus the absolute value of m. Well, m is -5. So if I take the absolute value of 7, I get 7. Absolute value of -5, we get 5. And then we'll add those two numbers together. 7 plus 5 gives us our answer of 12 on number 16. And then number 17. Before we even start, be sure you see there's a negative on the outside of our absolute values. That's the only time you're going to end up with a negative answer when you're dealing with absolute values. So on number 17, we know that a is -3. So inside the absolute value bars where I see a, I'm going to put in -3. So -3 plus -11 inside the absolute value bars with a negative on the outside. -3 plus -11 gives us an answer or simplified expression of -14 on the inside of the absolute value bars. We're going to, again, forget about the negative on the outside until we've simplified the absolute values, or what's inside the absolute value bars. Absolute value of -14 is +14, and only at that point will we think about the negative on the outside and take the opposite of +14, make it negative. So -14 would be our answer on 17. Next section, 18 through 21. The directions say simplify each algebraic expression given below. On number 18, -31a plus 14b plus 23a minus 19b. All we need to do on number 18, it looks like all we have is addition, addition, subtraction. We need to combine any terms that are like terms. So -31a and 23a would be like terms. 14b and minus 19b, or you can think about that as -19b, are like terms. Okay, I underline the terms that are like terms so that I know which ones to combine, so that I don't accidentally combine the wrong numbers or add or subtract the wrong numbers. Always remember to include the sign that comes in front of each term. That's going to tell you whether to add or subtract when you're combining these terms. The a's, -31 plus -23. When you combine those, we end up with -8a. 14b minus 19b. 14 minus 19 gives us -5, so I'm going to write that as -5b. We know that we have our answer in simplest form when we have no more like terms and no parentheses left. Number 19. On number 19, now we have multiplication, addition, and multiplication. Again, even when we're dealing with variables, we're still going to use the order of operations. So since we have multiplication here and multiplication here, we're going to do that before we even think about adding. So we need to multiply 3x times -7y. 3 times -7 is -21. And then our variables will be xy, -21xy. When we multiply the second half of that expression, 2x times 8y, 2 times 8 is 16, and our variables are xy. Now I'm going to bring down the plus sign. Only after we multiply are we going to add the terms together that are like terms. These two terms are like terms on number 19. -21xy plus 16xy, because they have the same variables with the same exponents. If we want to combine those like terms, we're just going to add the coefficients and leave the variables and exponents unchanged. -21 plus 16 gives us -5, and our variables and exponents are going to stay exactly like they are. So -5xy for number 19. Number 20. Looks like we have multiplication, we have parentheses, we have addition, multiplication, and an expression that we can simplify in parentheses again. So a lot of people like to do the distributive property anytime they see two terms inside of parentheses with a single number on the outside. It's going to make it a little easier on ourselves if we just go ahead and simplify inside the parentheses if we can. So Keep in mind, even when we have variables, we're going to use these order of operations. So parentheses, can I simplify inside the parentheses? If yes, then we'll do it. If we can't simplify, then we'll do the distributive property. So I'm going to subtract 9a minus 5a, which gives us 4a, and I'm going to look at this other set of parentheses. 2a minus a gives us a. So 2 times 4a plus 7 times a. Done with parentheses. Exponents, there are none. Multiplication and division. Those happen in the same step. We have multiplication here. We have multiplication here. 2 times 4a is 8a. 7 times a is 7a. Only then are we going to add or combine like terms. 7a plus 8a gives us 15a. A lot of people are tempted when they see an expression like this to go ahead and start adding and subtracting terms that are alike. They want to say 9a minus 5a plus 2a minus a, but keep in mind you have to multiply before you start adding. So combining like terms or collecting terms, as some of us say, is adding, which comes only after our multiplication in parentheses steps. Number 21. On number 21, we have parentheses again, but there's nothing that we can combine inside the parentheses or simplify inside the parentheses because we have different variables. So on number 21, now we're thinking distributive property. 2 times 5y, 2 times 3x. So we will, since we have addition and multiplication in this problem, we will multiply first. 2 times 5y gives us 10y. 2 times 3x gives us 6x. So we end up with 10y minus 6x. Then I'll bring down the 8x plus. At that point, now we only have addition and subtraction. Now we can combine any terms that are like terms. 8x minus 6x. 8 minus 6 is 2, so 2x. Nothing to combine the 10y with, so 2x plus 10y would be our answer on 21. So that's the first page. Number 22. Number 22 says employees of a company are reimbursed for the wear and tear that occurs on their car while on company business. One employee's odometer read 17,438 miles at the beginning of the day and 17,567 miles at the end of the day. How much would the employee be reimbursed if the rate is 48 cents per mile? So this person gets 48 cents per mile. That means for every mile. So we need to know how many miles that person drove. So if we take their ending odometer reading, which was 17,567, and we subtract what they started the day with, which it tells us in the problem is 17,438, we can figure out how many miles they drove. Again, we have to know that because we need to know how many times they're getting 48 cents. If we subtract those two values, 17,567 minus 17,438, we end up with 120 miles that individual drove. So again, they drove 129 miles and they're getting paid 48 cents per mile. That means for every mile. So what we need to think is to multiply 129 miles by 48 cents, and that'll give us the total that individual earns. $129 times 48 cents is $61.92. So that person would get $61.92 as their paycheck. Number 23, it says the radius of Mrs. Brown's circular flower bed is 3.5 feet. If she triples, this should say triples the radius, what will the area of her new flower bed be? So the radius of Mrs. Brown's circular flower bed is 3.5 feet. If she triples the radius, what will the area of her new flower bed be? Well, we know that she had a flower bed that looked like this. The radius was 3.5 feet, and it says that she wants to triple that. Well, if we triple it, then her new flower bed is going to have a radius of 3.5 times 3, which would be 10.5 feet. So this is her new flower bed. We want to know the area of that flower bed. Well, we know that the area formula of a circle is area equals pi r squared. We know that we can use 3.14 for pi, and we know that we're going to use 10.5 for our r, so 10.5 squared. So 10.5 squared gives us 110.25. 110.25 times 3.14 is going to give us our area. When we multiply those two, we get 346.185. Our units are feet, so square feet because it's area. 346.185 square feet. Number 24. Number 24 says Carly is traveling from Hattiesburg to New Orleans. The total length of the trip is 105 miles. If Carly averages 65 miles per hour for 1.5 hours before lunch, how many more miles must she have left to travel to reach New Orleans? So we're wanting to know then, if she needs to travel 105 miles and she travels 60 miles per hour for 1.5 hours, how much farther she has to go. Well, if we're doing anything that involves speed and distance and lengths of time, we know we're probably going to use the distance formula. Distance equals rate times time. Well, the information that it gives about her trip, it says that her rate is 60 miles per hour. That's her rate. Her time, it says, is 1.5 hours. So 60 times our time is 1.5. Our distance is what we don't know. How far did she drive during that amount of time? Well, 60 times 1.5, or you can think of that as 1.5, is going to give us 90. So the distance that she drove in that hour and a half was 90 miles. But the question is not how far did she drive, it's how much further does she have to go. We know that if her total trip is 105 miles and she's already been 90, then if we subtract that from the total, then we will get our distance of 15 miles that she has left to go. So on number 24, her distance remaining is 15 miles at the end of that hour and a half. Number 25, the area of a rectangle is 64 square inches. If its length is 16 inches, what is its width? I always recommend when you're talking about shapes, draw the shape. If it gives you any type of information as to the lengths or the measurements of that shape, then label it. So we know that the area is 64 square inches. It tells us if the length is 16 inches, we want to know the width. So I'm going to just put a variable there, x. Well, we know that the area formula of a rectangle is simply length times width. So if we fill in the information that it gives us in the problem, this is going to be our length. Then our area is going to be 64. Our length is going to be 16. And our width is what we're looking for. That's x, or I'll just leave it as w. At this point, this is just a one-step equation that we need to solve. 16 times w is 64, so we need to do the inverse operation of multiplying by 16. We need to divide by 16 on the right, divide by 16 on the left. 16 divided by 16 gives us 1, so 1w. So 64 divided by 16 is going to give us 4. So our units in this problem are inches, so our rectangle is going to be 4 inches. We can check that to make sure that we did it correctly. If this is 4 inches, 16 times 4 should give us 64. If it doesn't, then we know we messed up. Number 25 or 26. 26 says write which algebraic expression represents the perimeter of this figure. Okay, so this problem will probably be multiple choice on the test by the way that it's worded. So what we need to do on 26 is to find the perimeter. We know that to find the perimeter of any shape, all we need to do is to add up the lengths of the sides. Doesn't matter if the sides have variables or anything, we just need to add up all of the sides. So our perimeter in this problem is going to be 5x plus 4x minus 1 plus 3x plus 7 plus 6x plus 2. We've looked at simplifying these types of expressions on the previous page. All we have to do is to combine terms that are alike. 5x, 4x, 3x, 6x. When we combine all those, 5x plus 4x is 9x, plus 3x is 12x, plus 6x is 18x. So 18x when we combine the x's, and then we have minus 1 and plus 2 and plus 7. Minus 1, or negative 1, plus 7 is 6. 6 plus 2 is 8, so 18x plus 8 would be our answer. You can also just kind of look over here, and it's really a little easier to view it like this: 5x plus 3x plus 4x plus 6x, and then combine positive 7, negative 1, negative 2, or 7 minus 1 plus 2. So 18x plus 8. Number 27. Which algebraic expression represents the area of this figure? So this is a rectangle, so we know that the area formula of a rectangle is length times width. We know that the length and width are given to us. It doesn't matter which one we call which. We just need to fill those in for length and width. So I'm going to use 6 as my length. The width is 4x plus 3. There's a problem with the way that I wrote this, though, because this makes it look like we're just multiplying the 6 and the 4x, but we're multiplying the entire length by the entire width. So 6 times 4x plus 3. This changes everything, because now we need to do the distributive property to this expression instead of just multiplying two terms. So 6 times 4x, 6 times 3. 6 times 4x is 24x. 6 times 3 is 18. So our expression is 24x plus 18. Number 28, what is the circumference of the rim of a glass? So circumference, I already know that I'm dealing with a circle. Rim of a glass, if the diameter of the circle, of the circular figure, is 5 inches. So it tells us that the diameter, the distance all the way across the circle, is going to be 5 inches. We're looking for circumference. We have a circumference formula. Actually, we have two circumference formulas. One involves diameter, one involves radius. In this case, it tells us the diameter, so I'm going to use circumference equals pi d, pi times the diameter. So our circumference is going to be 3.14 times 5. 3.14 times 5 is 15.7. Our units in this problem are inches, so 15.7 inches. And then the back page. The directions say to perform the indicated operation in the questions below, given below using these matrices. So they give us matrix A, B, and C at the top, and then it tells us what they want us to do on each problem. So matrix A minus matrix B. Well, matrix A is written at the top, so matrix A is 7, negative 2, and 3. Matrix B is 2, negative 3, 1. If we subtract those matrices, we're going to get a matrix that's the same dimensions. 3 rows in 1 column, so we're going to have 3 rows in 1 column as our answer. Please be sure that you don't, at the end, subtract all of the numbers and get a single number as your answer. If you subtract two matrices, you're going to get a matrix as your answer that are the same dimensions as the two matrices that you were subtracting. So the way we subtract matrices is to subtract the numbers that are in the same positions or the same places in each matrix. So 7 minus 2 gives us 5. Negative 2 minus negative 3. Negative 2 minus negative 3 gives us positive 1. And then 3 minus 1 gives us 2. So we do top minus top gives us our top number. Middle minus middle gives us our middle number. Bottom minus bottom gives us our bottom number. That's all there is to, that's the extent that we go into matrices in Algebra 1. Number 30, it says negative 3c. That means negative 3 times c. So that's negative 3 times matrix C, which is given to us at the top of the page. If we're multiplying a matrix by a single number, we're going to get an answer that's a matrix with the same dimensions as the number, or the same dimensions as the matrix we started with. Really all we're doing when we're multiplying a matrix by a single number, that's called scalar multiplication, is we multiply each number, each term inside or cell inside the matrix by the number on the outside. Negative 3 times negative 5, that's negative 3 times top left, gives us our answer of 15 in our top left position. Negative 3 times 3, That's negative 3 times top right is going to give us negative 9, so that goes in the top right position. Negative 3 times 10, when we multiply those, we get negative 30. That's in the bottom left, so that's our answer is going to go in the bottom left. And negative 3 times negative 2 is going to give us positive 6, so that's going to go in the bottom right section. Number 31, this is the most confusing one that we are going to look at. What we need to keep in mind, and what we mentioned in class, is that you're always going to use order of operations, even when you're dealing with matrices. So this says 4 times a plus b in parentheses. So before I even write my matrices out, I know that I'm adding my matrices first, and then whatever I get, the resulting matrix, I'm going to multiply by 4. So let's write that out. 4 times a plus b. Matrix A is 7, negative 2, 3. Plus matrix B. Matrix B is 2, negative 3, 1. If we add these matrices, we've already talked about how to do that. Top plus top, that's 7 plus 2 is 9. Middle plus middle, that's negative 2 plus negative 3 is negative 5. 3 plus 1 is 4. So when we add our two matrices, or add the parentheses, then we get a matrix that is 9, negative 5, and 4. At that point, we're multiplying by 4. Now it's just like number 30. We're distributing that 4 to every piece of the matrix. Our result is going to be a matrix that's the same dimensions as the one we started with. So 4 times 9 gives us 36. That goes on top. 4 times negative 5 gives us negative 20. That goes in the middle. And 4 times 4 gives us 16. That goes on the bottom. So our answer to 31 is the matrix that looks like that. And then numbers 32 and 33, it says, read this paragraph and create the matrix that will answer the questions that follow. The Lewis family owns a franchise of the Stone Cold Creamery ice cream shop. Below is a record of how many sales they made using their vanilla and chocolate bases during a 2-day period in April. So they give us these two matrices, and we're going to use those on numbers 32 and 33. 32, it says, write and label a matrix that shows the total number of sales made at Stone Cold Creamery for the vanilla and chocolate bases for this 2-day period in April. So the first thing we might think about doing, if it says if we see the words total number of sales, is that tells us we're going to add. We're going to add day 1 and day 2. So for us to get our answer, we're going to add just like we did at the top of the page. 17, 16, 38, and 42. And to that we are adding 18, 19, 31, 39. So the most confusing part is to just read the problem and decide what operation we're doing. The actual math with matrices in Algebra 1 isn't difficult. So if we add those two matrices, then I know we're going to get an answer that's a matrix that is two rows and 2 columns. So we're going to add top left plus top left. 17 plus 18 gives us 35. Top right plus top right. 38 plus 31 gives us 69. 16 plus 19, when we add those, that gives us 35. And 42 plus 39, that's going to give us 70, 81. So this is our resulting matrix. Number 33, it says, during the 4th holiday, the Lewis family expects to sell 3 times as much ice cream as they did during the combined 2-day period given in the matrix above. Write and label a matrix that predicts how much vanilla and chocolate ice cream will be sold during the July 4th holiday. So we're going to take that matrix that we just had as our solution on the previous problem. Since it says 3 times as much, I'm going to multiply. Our result is going to be a matrix that is 2 by 2, 2 rows, 2 columns. We're going to distribute the 3 to all 4 pieces of our matrix. 3 times 35 gives us 105. 3 times 69 gives us 207. 3 times 35 again is going to give us 105. And 3 times 81 is going to give us 243. Now it said write and label. Well, we would label this July 4th, and we know that this first column is vanilla. We know that this bottom row is chocolate. We know that this left column is cups, and the right column is cones.